This is the Cisco Packet Tracer RIP configuration lab. To start off, let's look at the instructions here. We need to configure all routers with proper host name, enable login synchronous, no IP domain lookup. We need to configure point-to-point connections as shown, configure RIP2 on all routers, give your R1 and R6 LAN connections to the first IP of the network. Host A should be able to ping host B, and perform a ping from host A to B, then turn off R2 and ping again. Then after turn back, after a bit, turn off R4 and ping again. Your ping should still make its way to the other side of the network. So there is our test to make sure that our routing protocols will alert each other when a route goes down and will reroute traffic appropriately. So let's begin here. Configure all routers with the proper host name, enable login synchronous, and no IP domain lookups. Let's hop into R1 here. En conf t, let's do a host name R1, no IP domain lookup, and we also need to go into line console 0 and give it a login synchronous. So WR to save that configuration, and let's hop through these real quick with that same the same set of commands. You'll notice something with this one here. We go into the command line interface. So this device must be powered on. So Cisco and Packet Tracer, you do have the option to not just plug and unplug these devices here, like your 4 switching ports, etc. But you can also go in and act as if you're physically turning the machine on or off. So we just zoom in here and hit that pretend physical power button there. Then we go back in and we'll see the router's booting up now. So let's go back to that one in a second. Let's head on to R5. Seeing that we've been doing enable conf t hostname R5 no IP domain lookup line console 0. Give that a login synchronous. Exit, and write. Let's check back on 4. And our last one here is R6. Now, both these commands, again, they're really just quality of life things on our side here. The no IP domain lookup keeps us from accidentally typing in a command that it'll try to resolve to a host name. And the login synchronous just makes it so our text is easier to read as we go through shutting down our routers and turning them back on. All right, so that first part is done. Now we need to configure our point-to-point connections as shown. So if you remember with point-to-point connections, those are your /30 addresses that only give you 2 usable IPs. So in this instance here, it's saying to use the 10.0.0.0 network. Well, a /30 means the 0 is the network, 1 is your first available IP, 2 is your next, 3 is the broadcast. So we're going to go 1 and 2 here. So let's see here, what interface is this guy? Serial 001. Interface, serial 0/0/1. Give it a no shutdown, and give it an IP address. We said we can do 10.0.0.1. What our /30 subnet masks, that's 255.255.255.252. While we're in this router, let's go ahead and give this one its proper IP address. So we're using the network 10.0.0.8. First available IP is going to be .9. The last one's .10. And the broadcast is .11. So we're going to give this one the .9 here, and that is our serial 000. Go interface serial 000, no shut. IP address 10.0.0.9. Again, these are all going to be our /30s for these point-to-point connections. So 255.255.255.252. Give it do right there. Even though we did the no shutdown on serial connections, the line's not going to come up until we've configured both sides of this connection. So let's hop over to this serial one and give the other half of this network here. So CompT interface serial 0/0/1, no shut. IP address 10.0.0. Remember, 0 is the network, 1 is the first available IP that we gave to this interface. So the only other one on the /30 is .2. That's 255.255.255.252. And while we're in, let's go ahead and do this one. This is our 0. Oh, serial 0/1/0. All right, so serial 0/1/0. Interface serial 0/1/0. Give it a no shut. So the network here is 10.0.0.4. So that makes IP address. What's our first available IP? It's 10.0.0.5. 255.255.252. Now we gave it a no shut, right? Do it again. All right, so let's hop over to this interface, and we're just gonna hop around until we see all these connections pop up like they should. So let's see, what is the serial over here? Now for most of these labs, I'll make sure that these are the same interface, but that's not always guaranteed, so you always want to check there. Let's get back in here again. CompT interface serial 0/1/0. IP address 10.0.0. Which one? Well, the network is 4. We made this one 5, so this one's got to be 6. Give it a no shut. And again, now that both these lines have been configured as up, this interface will try to come up. All right, so we have this one configured. What about this other side here? Is that also our 0/0/0? CompT interface serial 0/0/0. IP address 10.0.0. Network is 8. We made this one 9, so the only other one is 10. It's a 252. Give it a no shut. We'll see this one come up here. What about this one here? So this is 0/0/1. Let's get out of this interface. Go into interface serial 0/0/1. IP address 10.0.0. This is the 16 network, so we'll go 17. These are all /30, so 252s. No shut. And let's see, this one here is serial 0/1/1. Interface serial 0/1/1. IP address. This is the 12 network, so we'll go 10.0.0.13. And we'll give this a no shut too. We do a do WR to write, just to make sure in case something shuts down, we don't lose all of our work. This is 000 on this side is the other half of that connection. So let's hop in there. Conf T, interface serial 0/0/0, IP address 10.0.0. This is the 12 network. We made this 13. So the only other one for this side is 14. No shutdown. We'll see that interface come up. There we go. Let's check out the other side of this link here. It is serial 011. Interface serial 0/1/1. IP address 10.0.0. You're getting the hang of this now. It's real simple. We just got we go in spacings of 4. So we have 0, 4, 8, 12, 16. Now we're at 28 is the network. So if 28 is the network, the first available IP is going to be just one more than that, 29. We'll give it a no shutdown. And a do, so I don't have to hit exit and go all the way out of here, do WR. We'll save the configuration there. So let's hop into router 4 here. Serial 0/0/1. Conf T, interface serial 0/0/1. No shut. IP address 10.0.0. Network is 16. We already used 17, so this must be 18. Let's configure the other side here. That's the serial 0/1/0. IP address. Let's see, what network are we giving this? The .20 network, 10.0.0.21. No shutdown. And a do WR. Okay, so this is configured now. Now for router 5. Conf T, interface serial /0/1/1. IP address of 10.0.0.30, because 28 is the network, 29 was this side, 30 is this side. Give it a no shut. Let's get over to the side. What is that? That's our 000 serial. Interface serial 0/0/0. So right there, you can see these links, link change status messages that have been popping up here, but it hasn't been interfering with our command prompts because we have that logging synchronous that every time a message pops down, it doesn't interfere. It automatically refills in whatever we were typing for us. So it's really handy. IP address. This is for the network .24, so 10.0.0.25, 255.255.252. No shut. Do right. All right, and the last two interfaces here is the serial 000 here. Let's see, is that right? Let's do the one first. So exit interface serial 0/0/1. IP address of 10.0.0.22. Give it a no shut. See that interface come back up. Once again, this one was the 000 interface. Yep, and we can see here that one. See if it'll let me mouse over that without taking it away. Yeah, but we can see by looking at this that the 000 interface is still down, just reinforcing that we haven't configured it. Sometimes it can be confusing when you have multiple interfaces right here to make sure you're looking at the right one. So it's our 000. Interface serial 0/0/0. IP address 10.0.0.24 network. We use 25, so this is going to be 26. No shutdown. All right, do right. So this is a lot of setup and configuration for this, and we haven't even gotten to these LANs yet. Let's go ahead and get these LANs configured here. So gigabit 0.1. Interface, gigabit 0/1. IP address. So this belongs to the 192.168.2.0 network /24. Now you can give your default gateway, that's what the router is in your network, is the default gateway. You can give that any IP address you want, but for the sake of remembering it, just best practice, always give the first IP address available in the network here. So we're going to do 192.168.2.1. This is a /24, so this is a 255.255.255.0. Give it enough shut. There we go. Do right. Let's hop over into this router. Let's see if this one is also gig 1. It is. So interface, gigabit 0/1. IP address. Again, best practice, let's give it the first IP available in the subnet. So we're going to give it 1. This is a /24 and a no shutdown. All right. So we've configured all of our point-to-point connections as shown. Now we need to configure RIP version 2. So like we said in a previous video, RIP is a really basic routing protocol, and you could still use it in your modern networks, but it's not going to perform nearly as well as OSPF or EIGRP will. We use it for this beginning kind of intro into routing protocols because it's a very simplistic routing protocol to watch, and it's really easy to implement as well. So we did a static routing lab, and you could go in here and configure your static routes here. You could say on this router here, anytime you're trying to get to from the 192.168.2 network and you're trying to reach someone on the .1 network, go ahead and just send out your traffic out your, what is this, our serial 0/0/1 interface. You can go ahead and just ignore the rest of this network here and say, just go out this way to reach that 192.168.1 network. The problem with static routers is maybe in a perfect world that would always be fine, but in a real world, devices go down, lines get dug up, cables get cut and broken, and routers go down. And if this router goes down here and you have just a static route configured, well, all the traffic coming from this network down here and trying to go out to .1 over here is just going to die, because it's going to say, well, I have a route to send it out 0/0/1. That's dead now, and it's down. I guess I can't go anywhere. Or even worse, what if it was an R2 that died, but it was this fiber link that was buried in between the two campuses here, got cut. And as far as this guy knows here, it's just sending out the traffic to 2 just fine like it should be, but it just dies there, and this guy really never knows why. Routing protocols exist because they will share all their known routes with each other, and when a route dies and it ages out of whatever routing protocol you're using, then the rest of the routers in the network will get informed that, hey, that network is no longer up and active and you can't use that anymore. So as we go through this last step here of pinging from host A to B, and then we turn off router 2 here, we should see the routing tables reconverge here, and router 1 and all the other ones here will know, hey, it actually our 0 networks down, our 4 networks down, we can no longer route over that. We're going to use the next best metric distance to transfer those packets over. So, but let's begin with router 1 here. So the command to start configuring your routing protocols is router. Let's put a question mark here. So you get the available routing protocols here. So OSPF, EIGRP are the other 2 major interior protocols that we're going to use. RIP is just kind of your intro protocol. So router RIP. There are 2 versions of RIP. They iterated on it, made version 2. So we're going to use version 2. And the only other command you need to know is network. This is where you're telling the RIP protocol, hey, go ahead and have these interfaces attached to these networks participate in your RIP. So we're going to do 192.168.2.0. So we're saying go ahead, do this network, include it in your routing tables that you're sending out, your RIP packets. We do network 10.0.0.0 and network 10.0.0.8. exit, and exit. Let's go ahead and save that. And we just have to go down the line and keep doing it throughout here. So router 2, it's a pretty simple one, right? En conf t. Actually, let's get out of here first. Let's do a, because I'm wondering why it timed out that quickly here. Maybe the rest will do that, but I want to do a show IP interface brief. Now do a type interface brief, and I want to see, just verify that it has the right IP addresses that it should. Okay, so 0/0/1, it does have 10.0.0.2, and the 0.10 does have 10.0.0.5. So it must have just timed out naturally. It did take quite a bit of time to configure all this. So let's get into the router configuration. Conf t router RIP version 2, and now we're just going to list off the networks that we want to participate in RIP. We're doing 10.0.0.0. Oh, not quite a full command there. Network 10.0.0.0 and network 10.0.0.4. Exit. All right. Let's do the same on router 3. Okay, this one looks the same. So it looks like we were just timing out because we did not set that executive timeout command. So router RIP version 2. And we're just going to list off again our attached network. So 10.0.0.8. We want our 16 network and our 12 network. Router 7. Let's get to our 10.0.0.12. Network 10.0.0.28. Router RIP version 2. Networks 10.0.0.16. Network 10.0.0.20. I want to see if this is starting to populate here. Let's go into R3 and I want to do a do show IP route. So that's what I want to see. We want to see these C's and L's, and you can look up at the kind of the appendix up here. You see C is for connected, L is for local. So we have our connected and our local. These networks are both because they're our local network and they're directly connected. But we want to see are these R networks. These are networks learned via the RIP protocol. So even though R3 here is not directly connected to this network because of the RIP protocol, R1 has shared this down and it knows of the 10.0.0 network. It also knows the 10.0.0.4 network right there because R2 has shared that down. It should also know about the 192.168.2.0 network, and there it does. So that's great. Just configured forward in it. Yep. So let's hop into 5. Exit router RIP version 2. Networks 10.0.0.28 and network 10.0.0.24. Exit out of here and save that. And the last RIP configuration we need to have here is router 6. So router RIP version 2. List off our networks again. So we have the 10.0.0.4. We have the 24 network, as well as the 20 network. But that's not all. This router is also connected to this local LAN over here. So network 192.168.1.0. So one of the downsides of RIP is it does not update its neighbors on with its routing table whenever an interface comes up or down. So if we go over here and do a show IP route, let's see, we're seeing the 1 dot. That's quick. Often, when you're configuring a RIP, you can get in before that initial RIP packet gets sent out where it's sharing this information about. But it happened pretty quickly here. But that's good to see that router 1 is getting packets from the other side of the network here, and it knows how to get to 192.168.1.0. Notice over here too, it does say via 10.0.0.2. So that IP address, it knows to get there, just send its information that way out this interface 001. And that's because RIP's a really simple protocol. It just uses hop count for its metric to decide what's the best route. So the best route from the 2 network to the 1 network, let's see how there's 2 hops here. That's much better than going 1, 2, 3, 4, or 1, 2, 3 to get there. And that seems like a good idea if these were all the same speed. But what if you had some old T1 line over here and a T1 line there? Well, maybe this is a 1.5 megabit connection going right here, and maybe this 1, 2, 3, 4 hop is all fiber optic, going at gigabit speed. That extra 5 hops doesn't really make much of a difference. It's much faster than the lower 2 hops. So that's another one of the reasons why we don't use RIP anymore. It's not smart enough to handle that. But for the purposes of learning, that's good enough. So let's configure our host A here. Desktop here. IP configuration. Let's give it a 192.168.2.2. Yeah, looks like Packet Tracer gives it the proper subnet mask. And the default gateway is 2.1. And let's hop over here and give this one the proper IP configuration too. So it's 192.168.1.2 and 192.168.1.1 is the default gateway there. Let's switch over to the simulation here so we can watch the packet traverse the network. Let's do a ping 192.168.2.2. You notice right away here, ICMP turns into an ARP message. There we go. You can see our packet traverse the network just like it should. And then we start to get lost in, STP protocol and things like that. But when we hop back in here, the first one should get lost, and we should see the other 4 follow through here. The other 3, I should say. There we go. And we saw when we did a packet tracer that it was going from R1 to R2 to R6, or actually we started on this side, so it's going R6 to R2 to R1, because RIP goes by hop count. But what happens when you shut this down? Let's go into the physical here. Let's just hit the switch and kill it. Let's do our show IP route again. Let's see if it's learned the right way to get there. So that interface went down and it immediately took that route out of its routing table. It doesn't know how to get there now. But there should be some routing information being shared around here that we should be able to figure out a different way to get to that network. There we go. So now RIP took its time to converge because again, RIP does, as soon as an interface goes down, it doesn't automatically update the rest of its neighbors to say, hey, this is down, update your table. No, it waits until the 30 seconds or whatever the default timer is for it to update. So we had to wait some time for that. But now it's gone through, and now it's saying you get to 192.168.1.0 via 10.10, which is this router right here. But that's not the whole story here, is it? Because it could go one of these 2 ways. So let's check out router 3. Let's see where it's decided to go ahead and send out its RIP. Based on what we know about RIP so far, which router do you think is going to get the next hop here? It should be router 4, right? Because RIP only cares about hop count. So if router 3 here is trying to decide what's the quickest way to the 1 network, 1 hop, 2 hop is much better than 1, 2, 3 hops. So let's see, let's do a do show IP route. And again, I did put the do in here because I was not back at the executive mode. I was in configuration mode. Let's see, we got 192.168.1.0 via the 10.0.0.18, which is this one right here. So again, we see RIP doing what it's supposed to do, where it chooses the best path by hop count here, which is 1, 2, and we can see that right there, 2. But what happens, let's shut down R4. See, once again, this connection died, and the protocol does not automatically go, okay, let me inform the neighbors here. R6 does not go, oh, this connection's down. Let me tell everyone how you get to the one network now. It's not doing that. It's going to wait until it's time to resend out the broadcast message to all RIP routers. There we go. It's come up. So 192.168.0.24 via 10.14. And that's this one right here. Let's take a look at what this router has for its route. Stretch this out a bit so we get, looks a little nicer. So 192.168.1.0, and you can see now the administrative distance for RIP is 120, and we can see four hops. And is that correct? 1 hop, 2 hop, 3 hop, 4 hops. Yep, we are good. So when you finish this lab, be sure to save your configurations and then save your file and submit it for grading. If you have any questions, please give me an email. I'll get back to you as soon as I can.